Hello students, today we're going to do a quick little review on triangles, and I want to add a rule that we haven't covered in class yet. This is kind of a shortcut rule, so it doesn't really change anything that you know, but it's a shortcut that might actually be beneficial as well for finding certain angles. So we know that angles in a triangle add up to 180. That is something that we've already covered in the previous class. And now today though, I want to talk about what's special about this kind of angle that's both a supplementary angle and an angle that is part of a triangle. All right, and so the thing is, I want to show you that you can approach this question with two separate methods. So we're going to try the first method here, and that is simply finding the angle through what you know about triangles. So if you're just looking at this side of the triangle, or the triangle without the line, then you could do some of the math here, and you'll know that x plus 40 plus 95 should total 180. If you do the math here, you're going to see that x plus 135 is equal to 180. And if you subtract 135 from both sides, you should get that x is equal to 45. All right, so that would be the answer there. Now, what if you went the other way? So now we're going to ignore the orange section, and we're going to focus on this blue section right here that I'm adding. Now, you could see that this is actually just a supplementary angle. And I could even go as so far as to cover the entire triangle here, and you could see that I'm left with just a supplementary angle. And so in this case, if we do the math, we know that supplementary adds up to 180. So x plus 135 is equal to 180. And you see that I'm left with a very similar equation to what I just had earlier. And I get that x is equal to 45. So with that, I could see that in both cases, the angle x is the same, which should be the case, right? Because it's part of the same image. So even though it's part of a line and part of a triangle, but the numbers need to add up. And that's a rule that we actually kind of secretly have. Now, with this, I want to point one more thing out, okay? We're gonna look at some similarities here, and I'm going to use the color orange here to represent the x, and the color blue to represent the other numbers. So there is something that's interesting that happens because of this. You don't even necessarily have to know what x is. All you need to know is if there is an angle that is, I probably should use the orange. Let's use that. If there is an angle right here, and it's surrounded, or it is part of a supplementary angle, and it is part of a triangle, then we are going to find out that this supplementary angle here is actually equal to this. Okay, so if you ignore that third angle, that shared angle, then you should get two numbers, one on the supplementary outside of the triangle, and the other parts of the triangle to equal. So how do we tell this? Well, we could start by taking a look at the two equations that we designed, right? And I'm just going to pull this closer, and I'm going to put them next to each other right here. So that's the angles from the triangle, and this is the angles from the supplementary angle. Now, if you take a look at this, we already see some similarities, right? You know that the x's are both similar, but also you know that the 180 is similar. So because these two are similar and you have an addition question, therefore these other numbers inside, whatever is left, must also be similar to each other. And so you'll see that the angle on the inside of the triangle, let's call these angle 1 and angle 2, and let's call this one angle 3. So if we see that this is angle 1 plus angle 2, and the other side you have angle 3, then what we're really saying here is if all the other numbers are equal, then therefore angle 1 plus angle 2 must be equal to that third angle. And so angle x is kind of in the middle there. That's the pivot point. That's the centerpiece. And so you should be able to conclude this equation is true based on that. So why am I bringing this up? Because once in a while you're going to get a question like this, and when you do, you can go ahead and just jump to this shortcut. You don't have to find out what x is. You don't have to necessarily know it. If you know it's great, it actually solves the question a lot more simpler. But to test your reasoning skills, we might make the question a little bit complex by not giving you the x, but you now know that you can find angles 1, 2, and 3 without even knowing what x is, assuming that you have angle 1, 2, or 3, like 2 of those angles. All right, so that is it. That's the addition to these notes.